Hi everyone, welcome back to the Frank little bench, and we have this time well, this is a power supply from Commodore. This is actually a VIC-21, but it is the same in Europe as the Commodore 64, and this kind of power supply is famous to go bad, and there is a reason for this, because it was quite cheap design, and as you may know, this power supply has two outputs. There's 9 volt AC and 5 volt DC. The 5 volt DC is obtained with the linear regulator, which is under the epoxy. This is, from what I read on the internet, is a 2 ampere version of the 7805. It is rated at 1.5 ampere at 5 volts. So this is gone bad actually, and it is not difficult to open it. There is a lid here, and you have to carefully try to separate going well, in this point there is a retention insert, another one in this point, and 3 smaller one in these places, so you can lift little by little on this side, then on this side, and this side, and again until it come off. I've got this one without the lid actually. Okay, here this is the PCB removed, and 2 of the diodes that I removed were bad, and you see the dark color in this part. It means it was getting very hot, probably for all its life, and at one time a couple of those diodes failed. Anyway, this power supply can be repaired using modern switch mode regulators that don't make much heat at all. And I had 2 choices actually to fix this power supply: either replacing all the diodes with the better ones, and then using a switch mode regulator board. As you can see, there is quite some space inside, so it could fit. Salvaging this capacitor, new diodes, removing all the other parts, including the linear regulator, or as I did, design my own complete board with diodes and switch mode power supply regulator and everything, LED, a little fuse here, this small SMD white component, and let's see how it works. Before going on, let's try to understand why switch mode power supply is much better than a linear regulator. Well, for power efficiency at least. Let's suppose we have a 5 volts regulator with a 5 ohm load, which means we have output current of 1 ampere. And let's suppose that we have a 10 volt input voltage before the regulator, which is not very different from what happens inside the Commodore 64 power supply, except maybe for the load. So what happens with a linear regulator is that the input current, this one, is almost equal to the output current, whichever it is the output current. Well, actually is slightly more than the output current, but the difference is very small with respect to 1 ampere at least. So power input and power output can be computed by multiplying the voltage by the current. So let's calculate the input power, in this case 10 volts by 1 ampere is 10 watts. The output power is 5 volts by 1 ampere, and it gives 5 watts. So power efficiency on this power supply is power out divided to the power input, which is 0.5, which is the 50% efficiency. It means that the difference of power output, power input, which is 5 watts, goes to heat. So we see that it's very inefficient. Okay, now we'll measure the actual switch mode power supply. We'll measure the voltage input, of course voltage output, which would be 5 volts or very close to 5 volts. And we have the load, the 5 ohm resistor, 10 watt 5 ohm resistor, and we have here a 1% 0.047 ohm 1% resistor to measure the current input. And I will use a power supply to the input, and the output is connected, of course, to our load. And the current sense resistor is read by this HP bench voltmeter. Well, it's there has a mathematical function that where I stored the resistor value, and it will divide by this value, so we'll read directly the ampere on the display. So let's do that. Okay, let's power on. So this is the output voltage, 4.92 volts, of course. This is the input voltage, which is 13.35. I'm measuring here. And finally we have the input current, which is almost well, let's say 0.41 amperes. So with the numbers that we measured, we have power input is 5.47 watts. Power output that I calculated with a different equivalent formula, which is voltage squared divided by the resistance of the load, and it gives 4.84 watts. So the efficiency is always power output divided by power input, and in this case it is 0.88, which means 88% efficiency, which is much better than the linear regulator. So the heat produced by this circuit is only, in this case, 0.63 watts, which is much different from the 5 watts that we found on the linear regulator case with a similar load. The efficiency in this case comprises also the losses in the diode bridge, and it's not much anyway, and I used low loss diodes even for the rectifier, which is another overkill of this circuit. I did not use regular silicon diodes like you would do in most cases. That means also that this power comes from in the C64 power supply comes from the AC transformer. So in this case, the power required from the transformer almost closely tracks the power required by the load, which is our C64. And it means that with this switching regulator we can supply almost twice the power to the load that we could do with a linear regulator, because the transformer doesn't see almost double the power required by the load, but it's see almost the same power required by the load in this case. So even the transformer will run cooler, and we can supply a bigger current to the Commodore 64. Like for example, if we have a power hungry expansion like the original Commodore RAM expansion, which required, as far as I know, different power supply to work on the C64. I think with this power supply modified, that expansion can be used fine without changing the power supply. But I don't have one to test, sorry. Yes, this regulator chip can supply 3 ampere. Just designed the port to be Y overkill and to stay on the safe side. So probably with the stock transformer we found on the C64 power supply, this port can run fine at 2 ampere at least. So much more than the required current from standard C64. Anyway, I put a 3 ampere fuse here, so it can run probably even a bit more than 2 ampere. And this is not cheap, it's not the cheapest option. If you want the cheapest option, you probably salvage the original board with the bridge and the capacitor, and you use a ready-made switching mode power supply board that you can find probably at 2 to 3 euros, while this chip alone costs 6 euro in a small quantity. So this was not really the cheapest option, but I like to design something that can replace what I'm trying to replace without making too much wiring and so on. So I'm going to mount this one into the original power supply and make some more tests. One of the problems with the switching regulators is the switching noise that appears on the regulated output So let's check on a real C64 how this noise looks like. First of all, I'm using an old unmodified C64 power supply, which is my original power supply, which is still working good with nominal output voltage. And let's probe on this point where the 5 volts is smoothed by this capacitor at the input of the C64, and we see some noise which is very low. It's like 50 millivolt one division, so it's probably 50 millivolts peak to peak in this moment, and it's low noise. Sorry, it's low frequency. It should be like 100 hertz. Now here I'm using the modified power supply. The system seems to work fine, at least on starting up. And let's probe the same 5 volts point, and you see it's different. I just turned the time base because now we have some high frequency spikes at the switching frequency, but the scale is always on the 50 millivolts per division, so the noise is higher, but it should not have any negative impact on the C64. Okay, I decided to run this demo to test the power supply. This is the last disc. This demo is from 2016, so it's a new one. Very nice, it's my favorite actually. And it runs better on the 8580 SID, so I'm using a C64C with the modified power supply. And it's on real discs with my 1541. So this is the last part of the demo. You find it on the internet and YouTube. It's very nice. I recommend you to look at this demo entirely, which is awesome in my opinion. So it seems to work fine. It seems it's working very good. So the power supply probably it's working well. It's not even getting warm, not at all. This would be the last test of this Commodore 64 power supply substitution. This is my original stock power supply, and we have a temperature probe. Temperature is 19 and a half degree. This is powered down, so temperature of the power supply it is the same of the ambient temperature. Now we'll turn on this Commodore 64 and run for an hour or so. Using a small basic program that prints the content of the time variable, and after an hour or so we'll check again the temperature. So as you can see, 1 hour 1 minute, almost 1 hour and 2 minutes elapsed, and let's check the temperature of the stock C64 power supply after 1 hour of operations, and it's well, 32 degrees and rising, almost 33 degrees. Let's say this is the temperature after 1 hour of operation on the stock power supply. Okay, I started a new test. Now ambient temperature is 1 degree more than before. We were at 19 and a half. Now we have 20 and a half degrees centigrade, of course, in this part of the world. Test started since 10 minutes, and this is the new power supply. I mean, the old one, but modified with my board, and I made a replacement lead for the power supply for this one, because when I found it was without the lead, and so now I made a replacement one to have a better comparison, because the original power supply has a lead, so there's not much air circulation inside, so now the comparison should be more fair. So this is after 1 hour, and taking a temperature on the same place as the other power supply, and the temperature is quite different from the other one. It was more than 33 degrees, and now we have 26, but still rising a little bit, but it's normal because it's powered on, and so difference is enough to allow a much cooler operation of the power transformer, which is inside here in this place, which is running much cooler than before with the linear regulator board. So well, it's still rising, so it will reach soon the 27 degrees, but it will take much more time than before to reach 33 degrees. So it's okay. It's the last test I'll do with this power supply. Then we'll replace also the other linear regulator board on the other C64 power supply that I left. Thank you for watching. Bye bye.